Hello and welcome to Behind the Scenes, where we take a look at a never-before-seen view into the world of differential equations. This is going to be some interesting stuff. For today, we're going to justify some things that we've been doing in the lecture. We are going to need a trig identity. That trig identity is cosine of x minus y is equal to cosine x times cosine y plus sine x times sine y. And let's go back to what we were doing with our undamped position function, and we also did this with the underdamped position function as well, because we could. So let's say that I have some function, let's say it's a cosine of omega t plus b sine of omega t. Now what I want to do is I want to think of an ordered pair. So we'll say think of the ordered pair a comma b, and plot this in the Cartesian coordinate system. So I'm just going to show how this would look in quadrant 1, but really shouldn't matter too much. So here's my ordered pair a comma b, which means I'm moving a units in the x direction and then b units up in the y direction. And from this, I'm going to want to create a right triangle. So there's my right triangle. So this is sort of without a loss of generality. We're going to use right triangle trigonometry to get an interesting result here. Now, this angle that I have, sort of closest to the origin here, I'm going to call this angle alpha. So that's an alpha there. And the hypotenuse, I'm going to call this c. Now, how would we choose c? Well, it's the hypotenuse of a right triangle, so we have that c squared is equal to a squared plus b squared, or then this implies that c is the square root of a squared plus b squared. So what I want to do is I want to go to my original form that I had of perhaps some undamped position function, and I want to take this, I want to throw it in parentheses, and I want to multiply this by c. But I can't just multiply by c arbitrarily. That's going to change what I have, so I have to multiply by c divided by c, which is just the expression 1. Now when I do this, what's going to happen is I want to leave c out in front, but the divided by c, I want to distribute that in. So then I have a over c times cosine of omega t plus b over c times sine of omega t. We chose c so that it was the hypotenuse of this right triangle that we create when we plot a comma b in the Cartesian coordinate system. Now since we have a right triangle here, that also means something very exciting. Sohcahtoa. Has anyone ever said Sohcahtoa to you, like directly at you? If you don't know what Sohcahtoa means, let me know in the course discussion board, but usually a lot of you have heard Sohcahtoa. It's just a little mnemonic device for remembering trigonometry of the right triangle. So let's talk about ka from Sohcahtoa. That's cosine is equal to the adjacent over the hypotenuse. Now in this case, we're talking about angle alpha. So cosine of alpha, ka, is the adjacent over the hypotenuse. The adjacent side is a, hypotenuse is c. We also have the so from Sohcahtoa, says sine of alpha is going to be the opposite over the hypotenuse, and here the opposite side of angle alpha is b. So then with these two identities, I can rewrite this a bit. So I still have c factored all the way in front, but then the 1 over c I distributed in. And we said in the purple that a over c is cosine alpha, and b over c is sine alpha. So now I have capital C in front, and then in the parentheses, I have cosine alpha times cosine of omega t plus sine alpha times sine of omega t. And now I can use that identity that we said at the very beginning. So I have capital C in front times This is going to be cosine of, and it should be x minus y. Here, think of, so let me show the identity again. Cosine of x minus y is cosine x cosine y plus sine x sine y. And think about x as being the omega t and y being alpha, though it really doesn't matter. But it just makes it look nicer. So we'd say x minus y is omega t minus alpha. If you do choose them in the opposite way, it doesn't matter because cosine is even. So cosine is an even function, which means that if I did pick them, well, let me say what it means first. It means cosine of negative x is equal to cosine of x. So if I pick this in the other direction, just sort of focusing on this, if I did cosine of alpha minus omega t, it's no different, because here I could factor a -1 out inside the argument. This reverses the subtraction to omega t negative alpha, which then just gives me cosine of omega t minus alpha anyways, since cosine is an even function. So this works out perfectly. Just for the sake of showing this derivation, it's easier just to say, well, let this be x and let alpha be y then. So we get that form directly. Now we remembered that picking alpha was kind of a bit funny, right? So we would try to pick alpha, but depending on what quadrant a comma b was in, we maybe had to sort of fix a bit. Let's talk about alpha. And alpha was found using tangent inverse. Let me draw a graph of the tangent function as best as I can and try to explain this as best as I can. So tangent, if you've seen it before, it looks, all sorts of crazy with these vertical asymptotes between negative pi over 2 and positive pi over 2, and then it repeats. As if we weren't listening, right? Repeats. Something like this. And then I can go ahead and get a bit of a legend here. So this is negative pi over 2, this is 0, this would be pi over 2, so this is pi over 2, so then this is pi, this is 3 pi over 2, and then this is 2 pi. Now depending on what quadrant I'm in, I'm going to have to correct the value that I get. And let me sort of try to make some sense of that. So we start by saying alpha is tangent inverse of b divided by a. And this makes sense if we go back to our right triangle. So we didn't mention from Sohcahtoa here that if I had tangent, that tangent of alpha would be equal to the opposite over the adjacent, which is b over a. And that if I have to solve for alpha, apply arctangent or inverse tangent to both sides. So then alpha is tangent inverse of b over a. However, when finding this on a calculator, it's not going to be straightforward. So if you get your scientific calculator, bleep, bloop, bleep, blop, bloop, bloop, then it's going to try to help you. But the calculator doesn't know what value to give you for tangent inverse. It has to be restricted to the principal branch of tangent to work with tangent inverse. The principal branch of tangent is this first one that we usually draw from negative pi over 2 to positive pi over 2. This is the principal branch of tangent. So no matter what, your calculator is only going to give you a value out for alpha that is on this principal branch of tangent. Let's talk about what could happen. Now, if we're in quadrant 1, that means a is positive, b is positive. That means we're somewhere between 0 and pi over 2. Somewhere between 0 and pi over 2 is already on the principal branch of tangent. So that's going to be fine. So if we're in quadrant 1, we're good to go, check mark. What if we're in quadrant 2? If we're in quadrant 2, then that means we're somewhere between pi over 2 and pi. If I'm between pi over 2 and pi, that means I'm on this strip of the tangent function. So for example, maybe I'm trying to find this value here. However, my calculator friend, bleep, bloop, bleep, bloop, doesn't know what I'm doing because he's, it's not very smart. It's a little robot. So it's going to spit out the value that is on the principal branch of tangent. So it's going to say, hey, I think you're talking about this value here. And it means well. It's not trying to, lead me astray, but it's not able to give me the correct branch of tangent that I'm trying to work on. it's my responsibility to know, hey, a comma b is in quadrant 2. My value for alpha then should be between pi over 2 and pi. So then in that case, I already am waiting for the calculator to give me the wrong value, but the right value is just a distance of pi away. So I have to add pi in this case. Now, what if I'm in quadrant 3? Well, it is sort of the same story in this case. So quadrant 3 means I'm between pi and 3 pi over 2, so somewhere on this piece of tangent. So maybe I'm here, for example. Now, my calculator doesn't know that. It doesn't know what I'm trying to actually find, so it's going to give me perhaps this value, something on the principal branch that is behaving similarly. But I have to remember, well, okay, so that's not going to be correct then. I also, in this case, have to add pi to have that correct value. Oh, and I think this is the first time I've ever tried to move my face. Hey, whoa, I'm over here. I'm so dizzy traveling. Just kidding. It's not that bad. Let's say I was in quadrant 4. So if I'm in quadrant 4, that means, A is positive and B is negative. So then I should have some value that's between 3 pi over 2 and 2 pi, which would actually be this little piece of the tangent here. So then maybe that's, for example, let me just draw something different. Maybe that's right here, right? And this would be quadrant 4. Well, in this case, we're going to have to add 2 pi because, oh, and I'm moving again. Where is he? So then my calculator is going to say, I don't know that you're working in quadrant 4, that you need something that's between 3 pi over 2 and 2 pi. So I think you're looking for this value on the principal branch, but that's not what I want. So in order to get what I want, I'm going to have to add pi and then add pi again to travel there. So that'd be a distance of 2 pi now that I have to travel if a comma b is in quadrant 4. So just to recap, if I'm in quadrant 1, tangent inverse of b over a is perfect. If I'm in quadrant 2 or quadrant 3, then I'm going to have to add a distance of pi units to get the correct value that I want for alpha. If I'm in quadrant 4, well, now I actually have to add 2 pi to get what I want. So I hope this sort of makes sense if we think about it in terms of tangent and how calculators react to the information that we feed into them. I think we can start to see a bit as to why I have to make these adjustments if I'm trying to work with the tangent inverse of b over a, which is always kind of dicey to work with because the calculator is confused a bit. But I hope this makes some sense as to how we can build the specific form. It takes great advantage of right triangle trigonometry, with a small caveat that alpha is tricky to find, but as long as we understand what we're looking for, where it is, then we should be able to find it and modify it so it behaves perfectly. Thank you so much for taking a look at this behind the scenes look at our material. I'll see you next time.